All right, people, let's rock those socks off some inverse functions. So there are some criteria that have to be met, just like the criteria that had to be met whenever we were talking about inverse functions back in algebra, when we were talking about that exponential, logarithmic, and the whole inverse function thing. The still same thing has to be met. In order to have an inverse, it has to be 1-to-1. And that's the deal. So, because these are infinite functions, right? You've got these periodic infinite functions that go on and on forever. In order to get something that is 1-to-1, you have to restrict that domain. So we are restricting sine around 0 because it's easier to do that. So we're hitting the maximum over here to the right and the minimum over here to the left, which means I'm rocking the socks off between negative pi over 2 to pi over 2. Now, also remember when we talk about inverses, the input and the output swap. Pardon me. So if I'm restricting my domain, that means my output now is restricted. So, goodness sake, sorry guys. So my output, I'm only going from negative pi over 2 to positive pi over 2. I'm going to scoot this down here because this is going to make an impact right here. Goodness, I got a frog in there. So here if I have inverse sine, this is one notation that we can look at it, or arc sine. Oops, it's right here too. My inverse sine or arc sine, both of those mean inverse, all right? This -1 looks like a -1 exponent, not an exponent. When you have that to the -1, you are not talking about an exponent. That is the sign for inverse. All right? 1 over cosecant is a reciprocal. This is not the same thing. So I want to say that one more time. This -1 is not an exponent. This does not mean a reciprocal. This means inverse. All right? That's important. You have to know your notation in math, and that's how we know our notation. So here, if we're swapping out these inputs and outputs, this is what my actual graph here of the inverse sine looks like, which means if my output is from negative pi over 2 to pi over 2, I am only on this right side of the unit circle. So notice this goes to a negative pi over 2. So if you're hanging out down here in this fourth quadrant, you are talking about negative angle measures. You're not talking about coming way down here and talking about something like 7 pi over 4 or something. No. That ends up being a negative pi over 4. It's negative angle measures down here, okay? So heads up on that. My domain can only go from -1 to 1, so my range is negative pi over 2 to pi over 2. If you're talking about actual inverse trig. So if I have this example here, arc sine of 1/2, so this arc sine just means inverse. What you're doing is you are asking yourself right here, what angle measurement goes with this 1/2? So what is my angle if my output is 1/2? Because remember those inputs, outputs swap. Remember sine is your y value. So if I'm looking here at pi over 6, my sine here is my 1/2. And whenever I'm looking at my unit circle, I always remember between pi over 6 and pi over 3, because wherever it hits, it kind of looks like it's at half. That's that 1/2. If I'm coming up here to pi over 3, my x hits at 1/2. But here, my pi over 6, so my answer here is pi over 6 because I have that 1/2. All right. So another example here, if I'm looking at this, what's my output or what angle measurement goes with -2? Nothing. Y'all, nothing. I can't have an input that's -2. That's not possible. It doesn't make sense. So then that one's not possible. I don't have to worry about it. But when you're doing your angle measures, that's the big deal right there. What angle goes with this value? That's the question you're always asking yourself. Okay, so let's look at cosine. The same thing's happening here with cosine. This is that forever periodic function, right? So now I'm going to restrict it. And so for sine and cosine, I'm going with the maximums and minimums. So I'm hitting it here at this maximum and hitting it here at this minimum. That's where I'm restricting. So for cosine, I'm going from 0 to pi, which is the top half of my unit circle. Still negative 1 to 1, right? Because it's still sine and cosine. But I'm going from 0 to pi. So cosine is the top half of the circle, where sine is the right. And the same thing, you can do this inverse symbol here to this negative 1, or arc cosine. It's going to end up being that same thing for you. And then we have tangent. So let's zoom in here a little on tangent. Now here's the beauty of tangent. Check this out. This thing is 1 to 1 right now. It's right now 1 to 1 for that middle period. Now I can't make it go for every single one, right? None of those will work. But from negative pi over 2 to pi over 2, I'm good to go. Which in turn does this, right? Instead of having horizontal asymptotes, I now have these vertical, instead of having vertical asymptotes, I now have these horizontal asymptotes from negative pi over 2 to pi over 2. This is going to make a big impact later with I have this inverse tangent. For now, let's just say, oh, cool, there's inverse tangent. So inverse tangent is the same values that my sine have from negative pi over 2 to pi over 2. All right, again, if I'm in this fourth quadrant, I'm not doing anything crazy. These are negative angle measurements in order to make that work. All right? Okay. Let's practice, shall we? So here's our first one. I want to say, what is the inverse sine of negative 1? So in order to get negative 1, you're going to make your unit circle. And I know down here is negative 1. Well, that's legit because it's going to be here. Now, this is not 3 pi over 2, right? We talked about that. You have to be that negative angle measurement, and this is that negative pi over 2 because I'm asking myself the question, what angle goes with that value? Same thing with cosine. There it is. What angle goes with that value? So if I'm looking at negative square root of 2 over 2, I know x values are negative to the left. So I'm coming over here, and that's my 3 pi over 4. So the real thing you guys are doing whenever it comes to this inverse is just looking back at that and saying, what angle measurement goes with this value that's happening here? And then you can pull that off. All right? Okay. So check it out. Let's practice some. If I have cotangent. Now, if I'm looking at cotangent, all the ones I know are sine, cosine, and tangent now, right? But if I want to find inverse cotangent, the reciprocal part of that is going to be this input value, right? So what would be the normal answer here? I'm going to take that reciprocal right inside here. So 1 over this negative 1 for tangent. This becomes tangent, and I get this reciprocal. So then where is inverse tangent? Negative 1, it's down here because I have, of course, tangent is sine over cosine. So if I have the exact same thing on the top and the bottom, that's what happens here. My cosine is positive, my sine is negative, and then that's where I have positive divided by negative. Notice this is negative pi over 4 because it has to be a negative angle measurement going down. Secant. With secant, you change that to cosine and get your reciprocal going for you right there with cosine. So if I'm going to look at my reciprocal, then I have cosine of 1/2. Well, cosine is this top part, where cosine is the positive over here at this 1/2, right? Then I've got pi over 3. All right. If it asks you to do degrees, because we've been doing radian this whole time, you don't have to. You could do degrees if it's asking you to put your answer in degrees. All right, that's 60 degrees. Up here, if it asked me to do degrees, then this would be negative 45 degrees, right? Typically, we work this in terms of radians is most common, but if not, that's fine. If you have something that's freaky deaky, right, not a normal thing, and it's cosecant, so that's good because remember cosecant's on the outside here. So outside of sine, so I'm going to take inverse sine of negative 1/3. Well, negative 1/3 is legit, right, because that's between negative 1 and 1. So then you just literally put that into your calculator. Inverse sine button at negative 1/3, and it pumps this out. It's just a calculator thing. All right. If it's something common on the unit circle, put exact answer, unit circle exact answer. If it's something crazy like this and it asks for the radians and to round to a certain value, then do that. All right. Cool. Rock the socks off this thing.